The Defense Research and Development Organization has provided detailed information about the stealth technologies being developed for India's advanced medium combat aircraft. The AMCA will feature monolithic, Kevlar, carbon fiber foam, and elastomeric radar-absorbing structures, as well as radar-absorbing paint to reduce radar reflections and enhance stealth characteristics. Monolithic structures integrate radar-absorbing properties into structural components, while Kevlar structures combine Kevlar's strength with radar attenuation properties. Carbon fiber foam increases electromagnetic wave absorption and reduces aircraft weight, while radar-absorbing paint absorbs radar reflections from exposed surfaces. Elastomeric radar-absorbing structures use flexible polymer-based materials around joints, panel interfaces, and other areas. These technologies, together with precise airframe geometry, edge alignment, serpentine air intakes, internal weapons bays, composite materials, and infrared signature reduction measures, will significantly enhance the AMCA's stealth capabilities. India's Project-18 next-generation destroyers are slated to become the Indian Navy's first surface combatants designed from the beginning to operate hypersonic missile systems. Project-18 destroyers are expected to have a displacement of around 13,000 tons and would feature a modular vertical launch system architecture that supports long-range surface-to-air missiles, anti-ship missiles, land attack cruise missiles, anti-submarine rockets, and hypersonic strike weapons. The destroyers are anticipated to be armed primarily with the BrahMos 2, as well as other indigenous hypersonic missiles that are under development by DRDO. Project-18 destroyers are also expected to feature electrical power generation, cooling systems, combat management architecture, modular launcher arrangements, advanced integrated electric propulsion, next-generation radar systems, enhanced stealth characteristics, and network-centric combat capabilities. The vessels are expected to enter construction later this decade and would likely be commissioned in the late 2030s. The Defense Research and Development Organization is gearing up to undertake another round of flight trials of its indigenous 500-kilogram PGM-5 precision-guided bomb. DRDO and the Indian Air Force are expected to conduct the trials jointly from the Su-30 MKI aircraft and will validate the weapon's aircraft integration, release characteristics, guidance performance, and overall system reliability. The PGM-5 is designed to provide the Indian Air Force with a domestically developed precision air-to-ground weapon for neutralizing hardened battlefield targets. The trials are expected to be undertaken in September and October this year, and if successful, would provide the IAF with another indigenous option for precision airstrikes. The Indian Army has started a repair and restoration program for 2 accident-damaged Heron unmanned aerial vehicles. The program involves IAI Malat and Indian company Elcom and covers engineering, repair, integration, and flight testing of Heron UAVs with tail numbers 332 and 345. The repairs include damage assessment, structural and propulsion-related repairs, replacement of required components, system reintegration, ground acceptance testing, weight and balance checks, and performance flight testing. The successful completion of repairs and flight testing would return both the UAVs to operational inventory and would replenish the Army's surveillance capabilities. The Defense Research and Development Organization has issued a tender for detailed engineering, design drawings, and soil investigation for a proposed Trisonic wind tunnel at Research Center Emirat, Hyderabad. The tender includes an estimated consultancy package value of 2.4 crore rupees and has an estimated contract period of 1,186 days. A Trisonic wind tunnel is designed to support aerodynamic testing across subsonic, transonic, and supersonic regimes, and is used to study changes in drag, pressure distribution, lift, stability, and control surface effectiveness at speeds of around Mach 1. The proposed facility would support aerodynamic research for missiles, unmanned systems, aircraft components, and other high-speed aerospace platforms, and could provide experimental data for validating computational fluid dynamics models.